Hey guys, I'm Jade. Today is my LeetCode review vlog on 106th problem. Construct binary tree from Inorder and Postorder Traversal. We are given two integer arrays, the Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree, and Postorder is the Postorder traversal of the same tree. We have to construct and return the binary tree. Let's see example 1 here to understand this problem easily. We got two input arrays, the Inorder and Postorder. We need to construct the binary tree by these two arrays and return the root node of the binary tree. Then, let's get started with our intuition to solve the problem. And the keyword is recursive approach with hash map. First, we need to understand the features of these traversals. The Inorder traversal would visit the left subtree first, and then visit the root node, and finally followed by the right subtree. So the elements to the left of the root node in the Inorder array represent the left subtree, and elements to the right represent the right subtree. Second, the Postorder traversal would recursively visit the left subtree first, then visit the right subtree, and finally followed by the root node. So all the nodes from the left subtree are the first part of the Postorder array, and followed by any nodes from the right subtree. And the last node in the Postorder array is the root node of the binary tree. With these features and information, here comes the solution of 3 steps. First, we need to find the root of the current subtree using the last element of the current Postorder array. Second, we need to locate this root node in the Inorder array. The elements to the left of the root in the Inorder array belongs to the left subtree, and the elements to the right belongs to the right subtree. Third, we'll recursively construct the tree and its left and right subtrees using the corresponding parts of the Inorder and Postorder arrays. Then, let's get started with our code and annotations to solve the problem. The very first step, we have to create a member variable, a hash map, and the code is private hash map of integer. Let's call it Inorder index map and assign a new empty hash map. We created this map to store the indices of elements in Inorder array, which can improve the performance of finding the root index in the Inorder array. Next, we have to implement the buildTree method. Inside the buildTree method, first, we have to fill the hash map with the mapping rules from the elements in Inorder array to their indices. So the code is for int I started at 0 and I should be less than Inorder array dot length and increment I after each iteration. And inside the for loop, we just put each entry into the map. Inorder index map dot put the value of Inorder of I and I itself, which is the index. And out of the for loop, we have to implement another help method. And we have to call the help method to recursively build the tree and return the root node. Let's say return, and we have to name the new helper method, which is, let's say, buildTree helper with 5 input parameters. And the first 3 parameters are the Postorder array pointer, with its start and end indices. And the last two parameters are the start and end indices of the in-order array. So let's write down the code. Post order, and the start point and the start index is 0, and end index is post order dot length minus 1. And the fourth element, the fourth input parameters, are the start index of the in-order array, which is 0, and in order dot length minus 1. Next, we have to implement the build tree helper method, and the code is private tree node build tree helper helper with 5 parameters. First is an post order, and second is post start, which is the start index of the post order. And the third is post end, which is the end index. And the fourth input parameter is the start index in the in order, int in start. And the final input parameter is in end, which is the end index of the in order. And inside the build tree helper method, first we have to check if there are any left elements to construct the subtree. If not, we just return a null node. And the condition is if post start is bigger than post end, or in start is bigger than in end. If so, we just return a null node. Next, we have to find the root node value of the current subtree, which is the last element in the current post order subarray. So we need to create a new tree node with this value to build this binary tree. So the code is tree node root equals a new tree node, and the value of it is post order of post end index. Next, we have to get the index of the root node of the current subtree in the in order array, and we have to use the root index in the following code. Root index equals in order index map dot get root node dot value. Next, we have to calculate the size of the left subtree. Int left size equals root index subtract in start. And by using the above informations and properties, then we can split the in-order subarray and post-order subarray into smaller left and right subtrees and continue the recursion. First, we have to recursively construct the smaller left tree, and the 5 parameters are the post-order array pointer with the corresponding start and end indices of the in-order and post-order array. And code is root.left equals build tree helper, because we have to reuse the method to do the recursion operation. But here we need another new 5 input parameters, as we already got the left size. So the index range in the post order of the smaller left subtree is from post start to post start plus left size minus 1. So the code is post order. This is the first input parameter, and the post start, which is the new start index, and post start plus left size and minus 1. And we also got the root index in the Inorder array. Therefore, the index range in Inorder of the smaller left subtree is from inStart to root index minus 1. So the code is inStart to root index minus 1. And that's the first part. And for the second part, we have to recursively construct the smaller left subtree. And then another new 5 parameters are post order array pointer with the corresponding start and end indices of the Inorder and post order array too. And according to the above information, the 5 parameters are just written below, which is root right equals build tree helper with post order, and the second parameters would be post start plus left size, because we'll start from the end of the left subtree. Post start plus left size, and the end index of the new post order is post end minus 1, and the fourth input parameter is root index plus 1, and the final input parameter is int end, which is an index of the new Inorder subarray. And until the end of the recursion, we just return the root node. Return root node. And that's all of the code for this problem. Let's submit the code and check for the correctness and analyze the time and space complexity. So the time complexity, it is big O of n, and n is the number of nodes in the binary tree. This is because we have processed each node once and perform constant time operations. This is because we created a hash map to get a faster search inside the hash map. And the space complexity, it is big O of n2. This is because we have created, we have to revise the code and resubmit again. And the space complexity, it is big O of n2. This is because we have already created a hash map before to store the indices of the Inorder array. And the recursion stack also used another big O of n space in the worst case, because we have used the recursive approach to solve this problem. And overall, the time and space complexity cannot found symbol, which is root index, cannot found symbol, post start plus left size minus 1, inStart, root index is here, cannot found symbol. Maybe I typed something wrong here. Post order. Sorry for that. Let me check it. Let me revise it and submit the code again. Yeah, the speed is a bit of slow, but let's wait for the check. Yes, our code got accepted. And this is the end of my LeetCode review vlog. on the construct binary tree from Inorder and Postorder Traversal problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the nodes for the top 150 LeetCode problems. For each LeetCode problem, you can see problem description, intuition, Java code with annotations, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the nodes and code to build this online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.